Hey, hello everybody. Welcome to the 3MT finals at the University of Alberta. I'm so happy to see you all here. My name's Dr. Tracy Rivio, and I'm the Vice Provost and Dean of the Faculty of Graduate and Postdoctoral Studies, and I'm going to be the MC today. I want to begin by acknowledging that the University of Alberta is located on Treaty 6 territory and respects the histories, languages, and cultures of First Nations, Métis, Inuit, and all First Peoples of Canada, whose presence continues to enrich our vibrant community. So I'm so excited to be here today, and I'm going to go off script just briefly. We're on a tight timeline, so not too long. But I think ever since I started this position on November 1st of last year, I've been looking forward to this day and this event. It brings me great joy. It is such an amazing example of what great communicators and researchers our graduate students are at the University of Alberta. And so we're in for a treat. So back to the script, so I keep us on schedule. I'm so pleased to be hosting this celebration of the more than 50 talented graduate student researchers and 15 finalists who took part in this year's 3MT competition. Now, I trust most of you in this room are familiar with the 3MT, but I think it's worth pausing to describe the rules of the competition, just to underscore what these young scholars have accomplished and how challenging this competition is. So a 3MT is like an elevator pitch in a very large elevator. Students have just 3 minutes to communicate the basics of their research project to a non-specialist audience. They can use only one static image to support their talk. Other than that, there are no slide decks, no props, nothing but their enthusiasm, their ideas, and their creativity. We in GPS are delighted to organize the 3MT every year, and this is our 10th annual competition. Wow, I didn't realize it was a decade. It's a decade. And we think it's an outstanding way to promote the value of graduate research to the larger community. I want to acknowledge some special guests who are joining us today. We have a room full of celebrities. So we are very privileged and lucky to have Kate Chisholm here, the chair of the Board of Governors. We have Peggy Garrity here, the chancellor of the University of Alberta. And I'm really pleased that Verna Yu, Vice President Academic and Provost, is able to join us today, as well as Brenda Hemmelgarn, the Dean of the College of Health Sciences, and Karsten Mundell, the Vice Provost of Learning Initiatives. Karsten, you're not sitting in the celebrity row. I don't know how that happened. You got away. Thank you for being here. We really appreciate it. Next up, I'd like to thank the 15 people, faculty members, senators, and postdoctoral fellows who contributed their time and expertise to judge the 3MT semifinals. There's a lot that happened before we got to this day. So you can see their names on the screen, but if the semifinal judges are in the crowd, are there any of you here? Maybe you can wave, get your recognition, and be acknowledged. Thank you very much. We really appreciate it. And now a very special introduction. I'd like you to meet 4 people who have taken on the Herculean task of judging the 3MT finals. You can see pictures of those folks up on the screen. We're fortunate to have 2 judges from the Edmonton community and 2 from the campus community to do this important work. First up is Saprit Buttar. Saprit is the CEO of the Universal Radio Network, a radio station focusing on first and second generation Canadians from the South Asian diaspora. She is also part owner of My Radio 580, Western Canada's largest ranged ethnic radio station, broadcasting in 17 languages, and is a recipient of Edify Edmonton's Top 40 Under 40 2023. Next, please welcome Trudy Callahan. Trudy is the publisher of Edify magazine. She and her late partner started Oddvod Publishing in 2006 with their first flagship title, Avenue Edmonton. She's also the founder and principal of Oddvod Media, a multidisciplinary marketing firm that is celebrating 25 years in business this year. And she chairs the board of directors of Ballet Edmonton. So let's give a round of applause for Sapreet and Trudy. Thank you so much for being here. We really appreciate it. We're so happy to engage our community outside of the university in this amazing event. From the U of A, we're pleased to welcome Dr. Darren Fast, Associate Vice President, Innovation, Knowledge Mobilization, and Partnerships. Darren's role is to develop and support a clear innovation strategy for the university, utilizing and coordinating existing resources across campus and the community. And finally, please join me in welcoming a champion of 3MT. Our Chancellor, Peggy Garrity, is returning to join our judges panel once again. Peggy is the 22nd Chancellor of the University of Alberta. For over 10 years, she served as Chief Reputation and Brand Officer at ATB Financial. She led the team responsible for creating ATB's story and transforming its brand in the marketplace. Thank you, Peggy and Darren, for agreeing to be our University of Alberta local judges. So I'd like to take a moment to invite Peggy up to say a few words of welcome on behalf of the Senate. The mic will even be the right height, I think.
That's true. Mics are at the right level for both of us. Thank you so much. I don't know why I'm feeling nervous. You are the ones that should feel nervous, but in a short while, I'm going to have to sit back there and have the horrible horrible task of trying to judge the winners of this competition. And I know that you are going to give me a really difficult task. On behalf of the University Senate, I know there's a couple of senators that are here. I wanted to congratulate all of the graduate students who participated in this year's 3MT competition. This really is a celebration of you, of all of you, of your contributions, and the importance of graduate student research, not only to each of you, but to our province, our country, and the world. Your research holds profound significance because it pushes the boundaries of knowledge and innovation, and it reverberates through our communities. It tackles some of the most pressing challenges of our times, and no matter what discipline you study, your discoveries and insights have the power to transform lives, inspire change, and pave the way to a brighter future. At the university, we talk about being difference makers and world shapers, and that's a perfect description of all of you and the work that you're doing. This is my 4th year being a judge, my last year, being a judge of the 3MT finals. I absolutely love it and look forward to it every year. It honestly, for me, is quite mind-boggling to see your ideas that you're working on and to see how simply you can describe those ideas, many of which seem incomprehensible to lots of us. And you always make it so difficult to choose a winner. In my professional life, I've seen the crucial role communications plays in explaining complex ideas, inspiring people, and paving the way forward. As you pursue your research, your ability to communicate as you're doing today will be vitally important to your future success in attracting support for your ideas and bringing your discoveries to life. I can honestly say that I work with some clients and leaders in organizations who could learn a lot from your ability to tell a compelling story in 3 minutes. As Chancellor, listening to each of you and learning about your work fills me with pride for our university and for all of you, and it brings a tremendous source of hope and optimism that the future is in good hands. Thank you once again for all the work that you do, and best wishes for your future success.
Thank you, Madam Chancellor. Next, I'm pleased to invite our provost, Dr. Verna Yu, to extend a welcome on behalf of the university.
So 3 for the height requirement here. When I got the invitation for the 3M thesis, I was so excited. But then my office reminded me that I was supposed to be in the air to Vancouver. So when they canceled the flight because of mechanical issues, I was so happy that I could be here. And I texted Tracy right away saying, I can be here this afternoon. This has got to be one of my favorite events. And for me, as I've said before, students, and especially graduate students, are the backbone of this university. It's what makes us who we are, takes us in our rankings, but most importantly, as I think our chancellor said, you are absolutely having a positive impact, not only within our campus, but on a broader basis. I just want to congratulate all the students who submitted their names for this competition, and especially to all of you for being in the final 15, and I look forward to being uplifted in the next 45 minutes of your presentation. So thank you, and congratulations to all of you.
Thank you, Provost Yu. And to all 4 of our judges, thank you for your commitment to our students. And now, buckle up, because the 2024 3MTs are about to begin. I will introduce our presenters today in groups of 5, and Rob will announce each talk and usher each speaker forward. There will be a short pause of less than 1 minute after each presentation to allow the judges to tabulate their scores. I told you it was going to be hard, but it'll be fun as well. So with that, our first 5 presenters are Jessica Van Oss, Ashra Manzoor, Ram Miguel Burtonshaw, Alexandra Gagnon, and Haley Waljean. I can't wait to hear your talks.
Great. Our first presenter, Jessica Van Oss, Department of Mechanical Engineering. Her talk is called Pathways to Net Zero Electricity in Alberta.
Can Alberta's electricity system get to net zero? What have you heard? Well, the fact is we can and we must. Greenhouse gases are the main cause of climate change, which negatively impacts your health, your environment, and your economy. Because of this, Canada and much of the world have agreed to reach net zero emissions by 2050, balancing emissions released with those that are captured or offset. And this all starts with electricity systems. That's where my work comes in. I'm modeling pathways to a net zero electricity system in Alberta under alternative carbon policies. Policies including industrial carbon tax and Canada's draft clean electricity regulations, which would directly limit power plant emissions. As an engineer, I love graphs. So don't be afraid. Let's take a look at these and the challenges ahead. On the left, we have emissions. Alberta, highlighted in blue, represents Canada's #1 source of electricity emissions, since many other provinces already operate fairly clean systems. Moving to the right, maybe we can see why. The majority of Alberta's electricity is generated from fossil fuels. So this represents a pretty significant shift in supply that will be necessary to reach net zero. The good news is, these graphs already look very different than they did only a few years ago. Successful policy and the growth of renewable energy has allowed Alberta to cut its electricity emissions in half since 2005, a trend that appears to be continuing, with coal soon to be phased out and a lot more clean energy under construction right now. But a long and uncertain road remains. Several factors like a unique market design, geography, industrial activities, and political tension complicate things for Alberta compared to the rest of Canada. Getting rid of coal was the easy part. Getting to net zero is a big challenge that will require policy solutions. My research uses optimization modeling. I run simulations to predict how the system could change into the future using different combinations of power plants while minimizing the total cost. The model decides what to do based on input costs gathered from academic and government sources that describe almost every aspect of an electricity system. On top of this, constraints are placed to mimic realistic conditions. For example, they reflect that the wind doesn't always blow and the sun doesn't always shine. We know. Results show that between now and 2045, Alberta may be able to reach net zero emissions, potentially before provincial estimations. Obviously, I can't predict the future, but long-term forecasting like this can help policymakers, stakeholders, and academics understand the impacts of different policies in reaching net zero, potentially ahead of provincial timelines and while maintaining a reliable and affordable system. Overall, my work aims to support decisions for a better future, hopefully changing what these graphs look like in 20 years.
Our next presenter, Ashura Mansour, Faculty of Pharmacy and Pharmaceutical Sciences. Ashura's talk is called Using Small Molecule Drugs to Stop the Spread of Cancer.
Good evening, everyone. Cancer is the leading cause of death in Canada. In 2023, 86,700 Canadians lost their lives due to this disease. In Alberta, every day, 60 people hear 3 words from their doctors: you have cancer. According to World Health Organization, in 2020, nearly 10 million people died worldwide because of this disease. According to Canadian Cancer Society, 2 in 5 Canadians develop cancer in their lifetime, and 1 in 4 people die because of this disease. Currently available cancer treatments such as chemotherapy, radiation therapy, and surgery are expensive, time-taking, and painful, and may result in anxiety and depression, and various other health concerns. So, in order to cope up with these major health issues, we need a treatment that should be easily available for everyone, less expensive, less time-taking, and less painful. So now, here comes my project. We are looking for immune checkpoint inhibitors. I am sure that all of you are curious to know that what are immune checkpoints. Immune checkpoints have revolutionized the cancer treatments. Immune checkpoints are specialized proteins on the surface of the cell. There are many types of immune checkpoints that are expressed both by cancer cells and immune cells, such as T cells. So, when a normal cell, such as T cell, tries to destroy the cancer cells, upon their binding, if a T cell is weak and is not able to destroy the cancer, as a result, the cancer cell will inactivate the T cell, and the cancer continuously grows and spreads in your body. So this is our main aim. Our basic purpose is to inhibit this binding through small molecule inhibitors. Among these various types of immune checkpoints, we are going to target TIM3 that is expressed by the T cells, and we will stop its binding to a protein called galectin-9 that is expressed by the cancer cells. We are expecting that our drug, that will be a small molecule, will bind to the TIM3 instead of the galectin-9, and the T cell remains active. And the most amazing benefit of these treatments is that it will boost your immunity, stop the spread of cancer in your body, And most amazingly, if the cancer reappears, it will immediately recognize those cancer cells in your body and destroy them. It means it will provide long-term benefits to the people. That's all from my side. Thank you so much.
And our next presenter, Ron Miguel Burtonshaw, Neuroscience and Mental Health Institute. Ron's talk is called Helping the Brain Help Itself.
So, strokes are a leading contributor to adult deaths and disabilities, with disease prevalence and burden having increased greatly from the 1990s up to today. Part of the problem is that many stroke patients today still leave their treatment and rehab regimens with some level of a permanent disability. And the thing is, our own brains might be partly to blame. You see, in our brain surrounding our neurons exist these specialized structures. Think of these structures like a sort of bird cage. So normally in a healthy brain, this bird cage is generally protective. So it promotes stability, it helps clean up bad proteins, and it even prevents bad abnormal connections from forming between your neurons. Now this is all fine and dandy. However, in a brain injury, like say a stroke, this bird cage becomes more restrictive, and this environment now becomes detrimental to your neurons. You see, in a stroke, some neurons inevitably die, but some affected neurons can be saved if they get the right support quickly enough. And the thing about this bird cage becoming more restrictive is that these hinder these neurons from getting that proper support, because in being more restrictive, it prevents growth, it prevents repair, it prevents these neurons from making new connections that could potentially help the patient recover after a stroke. Essentially, this birdcage is hindering your brain's own ability to repair itself. Sure, one idea that people have had would be to get rid of this birdcage altogether. However, you don't necessarily want to get rid of this birdcage because, remember, they're generally protective and they're there for a reason. However, this brings me to my research, which is on this protein called PTN. PTN is a fascinating little protein that does many, many different things all over your body. But what we're interested in is how it interacts with this birdcage in your brain. You see, what our lab has found is that PTN can talk to this birdcage and change this restrictive environment into one permissive for growth. And what's even more exciting is that in my own research, I have found giving this protein to a mouse brain after a stroke leads to an increase in pathways conducive to growth and repair, allowing for these neurons to grow, to rewire, and make new connections that could potentially help in recovery after a stroke. Essentially, in this sense, PTN is acting kind of like a key that lets your neurons spread its wings out for a bit. Now, this work is exciting for two reasons. One, in learning more about PTN's role after a stroke, we are hoping that it can help supplement current stroke therapies and improve the overall functional recovery of patients down the line. Secondly, this approach on repair and rewiring can potentially be applied to other treatment paradigms for other brain injuries and disorders. And this is all important work because in learning more about promoting growth and uncaging our brains, we're working to help the brain help itself. Thank you.
Our next presenter, Alexandra Gagnon from the Department of Sociology. Alexandra's talk is called Remand, Release, Reconvict.
Growing up, I was often told about how awesome recycling is. Many of us have heard the phrase reduce, reuse, recycle, and have seen the 3 arrow symbol behind me. It's a genius system, as once something enters it, it is forever in a cycle of reproduction. It's an environmentally friendly process. While keeping plastics out of ecosystems is a great idea, doing the same with people who are incarcerated is not. I study what's known as the cycle of reoffending, and I find that it's similar to the idea of recycling. When a person goes to prison, they don't come out reformed and ready to contribute to society. Instead, we're seeing that they become trapped in a cycle of release and imprisonment. They cannot get out of it. When prisoners have reduced access to social programming and we reuse tactics that are not working, we end up with the recycling of human beings in our criminal justice system. And unlike recycling plastics, this is not sustainable, and it must be addressed. I'm part of a team working to tackle this problem through the University of Alberta Prison Project. We are conducting interviews and surveys in Western Canadian provincial institutions with 800 incarcerated people, and we'll follow up with them 6 times post-release from prison. This is the first systematic study on barriers to re-entry in Canada, and will tell us what challenges formerly incarcerated people face and why around half of them end up back in prison. For example, consider John, who I interviewed on his day of release at age 28. Having first been incarcerated at 19, the longest stretch of freedom John had known was a mere 3 months. Shockingly, he told me about his intentions to return to prison. Why? Because he needed urgent dental care for a tooth abscess, a service only accessible to him in prison due to the high costs on the outside. Despite having a dental appointment scheduled for the very next day, this critical aspect was overlooked in the decision to release him. Trapped in the cycle of reoffending, Stats Canada tells us that each year of John's incarceration costs Canadian taxpayers an average of $119,000. However, if we choose to invest in social and correctional community services aimed at addressing John's needs, we can reduce this cost to $31,000 a year. With almost 3,000 people incarcerated in Alberta alone, the stakes are not just human, it's also economic. Through our research, we will identify effective social services, pinpoint areas for improvement, and create the first evidence-based policy recommendations to end the recycling of human beings in our criminal justice system. Thank you.
Our next presenter, Haley Wall-Jean from the Department of Agricultural, Food, and Nutritional Science. Haley's talk is called Feeding the Farm with Fish, Try an Alternative Dish.
How can a steak dinner fill you up, but leave you with an empty stomach? Steak is filling, but the cow that steak came from required a lot of food to get to your table. In fact, some of it's food you could have eaten, like sardines and soybeans. So even though that steak sates your appetite tonight, the cow might have eaten the food you need tomorrow. So why are we feeding sardines to something that will end up as steak? Well, most livestock need protein supplements, which are usually from soy or fish. As our population and meat demand continues to rise, we're ramping up deforestation to grow more soy for animals, not humans. We're also overfishing our oceans and destroying its biodiversity. Together, these activities are exacerbating the climate crisis, food insecurity, and world hunger. But what if I told you there was a way to have your steak and your sardines? We need an alternative dish to feed livestock, and in my lab, we're making protein from bacteria. Each bacterium is a single cell, and since they're high in protein, they're called single-cell protein. Single-cell protein is made through fermentation, where bacteria is placed in a tank along with water, nutrients, and oxygen. Here they grow and multiply, resulting in a liquid that is rich in these high-protein cells. But that's not the final product. To get to the final product, I am developing filtration systems to separate the bacteria from the liquid, as well as drying methods to get a powder that can be added to animal feed instead of soy or fish. Now, this may sound straightforward, but since the goal of my project is to add another protein source for the entire animal feed industry, I need to think on a massive scale and make sure single-cell protein is competitive with soy and fish. Could you imagine digging a garden, planting and growing your own potatoes, then laboring over a batch of homemade French fries, only to find that they're less healthy than a bag of frozen pre-cut fries? My process also has multiple steps, and I need to monitor each one to make sure my final product is of high quality, high purity, and highly nutritious. So what does this mean in the grand scheme of things? Well, if we can make single-cell protein instead of growing soy, we can substantially reduce deforestation. In fact, one production plant in 1 year can save a forest the size of Banff National Park. We can also help replenish our oceans and increase global food availability. Because with single-cell protein being used for animal feed, there's more sardines, soy, and steak for us. Thank you.
Okay, so I'm a microbiologist, but I have never thought about bacteria in that way before. So I learned so much from those first 5 talks. Thanks, everybody. So now I'd like to introduce our second group of presenters today. We will have Brandon Tyre, Amy Callahan, Megan LaRock, Rafay Osmani, and Janani Radhakrishnan. Okay, I can't wait to hear the next 5 talks.
All right, and as Tracy said, our next presenter is Brandon Tyre, Department of Biological Sciences. Brandon's talk is called Legs, They Don't Need Those.
Studying dinosaurs is hard, not just because it can be a challenge to go out to the field and excavate the bones, but because the bones we get are often broken and don't come as part of a complete skeleton. Occasionally, we'll get lucky, and we'll find something as beautifully preserved as this skeleton housed at the Canadian Museum of Nature. But most of the time, what we get looks a lot more like what we see on the left. A couple of broken bones, maybe scattered with a few other broken bones. Yet, we don't know what species this skeleton belongs to, while these few skull bones are enough to define an entire species. Why? Because the study of this group of dinosaurs, a group called ceratopsids, and including the famous Triceratops, has focused almost exclusively on the skull. That means if you don't get a skull, you don't know what species you're working with, even if you have every other bone in the body. My research is working to change this imbalance. For years, paleontologists have had this focus on the skull because they've assumed that bones besides the skull look the same in different species. I've been testing this idea by going to museums throughout Canada and even in the US, looking at the bones that they have on display and behind the scenes, taking pictures, making measurements, making notes. And what I've found is that there actually is a lot of variation between specimens. For example, the largest bone in the pelvis, called the ilium, highlighted here in yellow, is strongly curved and S-shaped in some species, but nearly straight in others. Another bone in the pelvis, highlighted in orange, has a blade sticking off the front that has a different shape in different species. A bone in the lower leg, highlighted in green, has a part sticking off to the side that in some specimens is straight and in others is curved. These sorts of variations, though sometimes very subtle, are how paleontologists determine what different species are and how those species are related to each other. More similar species are more closely related to each other. The next steps for my research are to take the variation that I found and see what that tells us about the relationships and therefore evolution of these animals. My initial results show that some of the variation that I found maps really, really well with our current understanding of how these animals are related to each other. But other variation doesn't match so well, suggesting that perhaps there's a more complicated picture when it comes to the relationships and evolution of these animals. This research is opening the door for new discoveries by starting a conversation about the legs and pelvis of these animals. In the future, when paleontologists think of this group of dinosaurs, hopefully they'll think about more than just the skull and ask questions about the rest of these animals' bodies. Because after all, these animals do need their legs too. Thank you.
Our next presenter, Amy Callahan from the Department of Surgery. Amy's talk is called Kids Got Nerves.
Do you remember when you were in grade school and you had to talk to your crush for the first time? Do I look okay? Do I smell okay? My hands are sweaty. Is my face gonna turn red? What if I sound dumb? What if my voice cracks? That takes a lot of nerve. My project is on the actual nerve that lets you talk to your crush, sing in the shower, or yell at the TV when the Oilers break their winning streak. See, there's a nerve called the recurrent laryngeal nerve. It starts at one of the main nerves in your spine, loops around a part of your heart, and comes up into your larynx, or what most people know it as, your voice box. Your voice box is important. It connects to your lungs, so it acts as a passageway to let air in and out as you breathe. Your voice box houses your vocal cords, and those move together, apart, tighten, and loosen, and they create different volumes or pitches of sound. It also acts as a barrier to make sure what you eat and drink doesn't go down the wrong pipe and end up in your lungs. If this nerve is damaged, you can have trouble speaking, swallowing, or even breathing properly. And people who have heart surgery can have this problem because that nerve runs around your heart. So that nerve can get damaged easily. Now imagine you're in school and you have this nerve problem. And on top of everything else, you're also self-conscious of how hoarse or airy your voice sounds. Or you're the one that's always coughing and choking on their lunch because you actually can't swallow properly. Imagine not being able to speak loud enough to present a project to your class or communicate with your teammates when you're playing sports. Imagine how frustrating it would be to speak and not be heard. One damaged nerve seems like a small side effect of having this high-risk heart surgery, but when you look a little closer, you can see this can affect someone's quality of life in all kinds of ways. Now, there are some surgeries that can help this voice box nerve problem, but the most common options offered for kids are only temporary fixes. My research is looking at a surgery that's a permanent fix. This surgery connects a working nerve to that damaged nerve. So it creates a detour for your brain to send signals to your voice box and get your vocal cords to work again. My project is going to follow patients that have had heart surgery at the hospital to see what kinds of symptoms and treatments they have. The goal is to see how common this nerve problem is, how big of an impact it has on kids' lives, and how this surgery can fix it long term. Growing up is hard. Talking to your crush, joining the basketball team, playing the saxophone, finding your style, finding your path, and finding your voice. Finding your voice and using your voice. We want to make sure kids can use their voice and that doctors and surgeons know the best way to make this happen. We already know, kids got a lot of nerves. Let's make sure they can use them. Thank you.
Our next presenter, Megan LaRocque from the Department of Biological Sciences. Megan's talk is called To Go or Not to Go.
Let's imagine it's a snow, cold winter night and you're just craving a slice of pizza. So you hop into your vehicle and traverse the icy roads of Edmonton all the way to the pizza place just to find out that it's closed. What a waste of time and energy, and you've missed your favorite episode of TV in the process. Wouldn't it have been nice if one of your friends would have told you that it was closed? Well, in the harsh winters of Alberta, black-capped chickadees, famous for their backyard call, Chickadee, also have to make decisions about where and when to get food, except whether the food is actually there or not is a little more of a life and death scenario compared to you missing out on a cozy evening in. In the winter, low temperatures combined with low natural food availability make every movement made by a chickadee a loss of essential resources necessary to survive the next day. In order to make the best decision about when and where to get food, chickadees can use one of two strategies. They may either be like the chickadee in the yellow toque and visit the feeder themselves, kind of like you driving out to the pizza place. Or they may be like the chickadee in the blue toque and watch the behavior of their flockmates, deciding maybe not to visit a feeder if their friend comes back with no food in beak. Now, some chickadees are more likely to wait for a friend to visit the feeder first than others. We all know that person who would drive out regardless of the road conditions to grab a slice of pizza. In my study, I asked, under what circumstances will chickadees use information from flockmates when deciding to visit a feeder that doesn't have food? In our population, chickadees have leg bands, which read like barcodes at each of the feeders that they visit. So when a chickadee visits a feeder, I get to know who visited, which feeder, and when. I will assess which chickadees never visit an empty feeder. In other words, which chickadees knew the feeder didn't have food, even without having to visit it themselves. Then I will see which chickadees survive the winter. If the chickadees that never visit an empty feeder are also better at surviving the winter, then those chickadees have the best strategy for gaining information about their environment. This will allow me to better understand how chickadees make life and death decisions amidst harsh winter conditions. It will also expand our understanding about how animals will make decisions in a rapidly changing world. To go or not to go? The next time you ask yourself that question when deciding to leave the comfort of your house and search for pizza, remember the chickadee who asked the same question, yet instead of the risk of missing out on a cozy evening in, risks spending precious resources necessary to survive the next cold winter night. Thank you.
Our next presenter, Rafay Osmani from the Department of Laboratory Medicine and Pathology. Rafay's talk is called Save the Fish, Freeze Some Water.
Imagine you're on a beach vacation, the sun warms you from above, and the ocean waves cool you as they come in. You're surrounded by friends and family, and today you're all going on a very special tour. It's a historic underwater tour of a graveyard that was once a majestic coral reef. We're not there yet, but our oceans are dying. There's many governments, groups, and policies that are trying to fight off environmental changes, overfishing, and pollution. But today's projections suggest it might be too little too late. It's a bleak thought, yes. And that's what makes me so driven about my research in cryopreservation. Just think, if we can take fertilized fish embryos, store them indefinitely at sub-zero temperatures, and thaw them without them dying, we'd be able to reintroduce these species back into their natural habitat when it is safe to do so. But it's difficult to get the biology of fish embryos to agree with the chemistry of cryopreservation. Cryopreservation uses chemicals called cryoprotective agents that are very similar to the antifreeze windshield washer fluids we put in our cars. But the goal is to prevent ice from forming. But it's easy to get antifreeze windshield washer fluid into a vehicle, whereas embryos have many barriers and seals that prevent chemicals from getting in. And rightfully so, because research finds that anything above a minimal concentration of these chemicals can be lethal to the embryo. Theoretically, we want no ice formation. But in reality, there's a certain amount of ice that can be recovered from. Think of it like first-degree frostbite versus severe fourth-degree frostbite. The smaller the ice crystals, the safer it is for the embryo. That's where ice recrystallization inhibitors come in. These inhibitors are small molecules that instead of focusing on preventing the formation of ice, they focus on preventing the growth of ice. But they've never been tested in fish before. We hypothesized that these small inhibitors could weasel their way into an embryo and improve cryopreservation outcomes. We recruited the help of zebrafish because they're easy to maintain, produce a lot of embryos, and their embryos are very representative to those of many other fish animals. So far, my research has yielded 3 compelling results. 1, that getting these inhibitors into the embryo is as easy as mixing it into the same water. 2, regardless of the duration of exposure, these inhibitors have no toxic or consequences on the developmental outcomes. And 3, most importantly, when looked at under a microscope, and when we look at the muscle cells of these embryos, we can see significantly smaller ice crystals than the groups that did not have the treatment. We're certainly a long ways to go before we can fend off extinction with this technology, but we sure can get there before your 2050 beach vacation. Thank you.
Our next presenter, Janani Radhakrishnan from the Department of Agricultural, Food, and Nutritional Science. Janani's talk is called Saving Canola from Narcissistic Relationships.
Can you believe that one of the valuable daughters of Canada, despite contributing billions of dollars to the Canadian economy every year, is being harassed by a microscopic bully? Well, sympathies for her, but why should we care? Well, we should, because she has been giving us and millions of people affordable and healthy cooking oil. Yes, she is canola, the Canadian oilseed crop. And this pathogen is a soil-borne pathogen manipulating our princess canola and resulting in the formation of huge tumor-like galls in the roots, just as shown in this picture. This disease is called clubroot. This restricts the absorption of water and other nutrients and ultimately leading to poor quality seeds, oil, and many a times early death of some of these victims like the one shown to my right. Well, we've got two options to save canola. One is to eliminate the bully, that is, use some pesticides to kill the pathogen. Or you can choose to empower the victim, that is, make our canola plants resistant to these pathogens. Although there are many genes for resistance already available, the challenge here is that these pathogens keep evolving rapidly, just like different strains of the coronavirus, and are capable of breaking this resistance. And that is where researchers like me come in to explore new genes for resistance, like the dehydrin gene family. So this dehydrin gene family is already present in canola, and they have the recipe to produce certain proteins that help canola overcome stresses like drought and frost by acting like a warm piece of blanket. But what about protection from pathogens? Well, a recent research shows that some of the survivors of this clubroot attack, like the one to my left, have abundance of these dehydrin proteins compared to the victims. But does that mean dehydrins are able to fend off these pathogens? That is exactly what I'm trying to find through my research. That is, I'll be using little bacterial messengers to give instructions to a model plant called Arabidopsis to produce more of these dehydrins and see if it will improve the plant's resistance to clubroot. And we use this model plant because it has a shorter life cycle. If this is successful, then dehydrins will act as one of the chaperones, protecting our valuable princess canola from these heartbreaking relationships, or in this case, root-breaking relationships, so that you and I can get heart-friendly cooking oil. Thank you.
Wow. I'm really glad I'm not a judge. This has been really amazing so far, and we're not done. So we have 5 more speakers. Are we ready, Rob? Yeah. Our final group of 5 will be Sarah Biddle, Alexis St. Pierre, Sophie Benaroya, Chris Chang Yen Phillips, and Arushi Tundin. Can't wait.
Thank you. As Tracy said, our next presenter, Sarah Biddle from the Department of Earth and Atmospheric Sciences. Sarah's talk is called, Can Ancient Worms Help Predict the Future?
What if I told you there's something every person in this room has in common? And even further, it's something we all have in common with every animal that's ever existed. That is our need for oxygen. Now, as humans, the lives that we live are dictated by the resources available to us. Here in Edmonton, these resources might be the wood and the concrete we use to build our homes, or the natural gas we use to heat these homes. But for some animals, a major resource that determines how they live is the availability of oxygen around them. And this is particularly true for animals that live within the ground. And just like humans, these animals that live within the ground also build homes. But instead of wood and concrete, their building material of choice is the sediments around them. You might actually be familiar with these sedimentary homes I'm referring to, as I study worm burrows, or the tubes and tunnels beneath our feet left behind as worms migrate through the sediments. Specifically, I study marine worm burrows, or the homes of the worms that live in the sediments beneath the oceans. Now, the burrows that I study weren't built today. They weren't built yesterday. They weren't even built this century. They were built 100 million years ago and are preserved as fossils in ancient sedimentary rocks. But why do we care about the homes of 100-million-year-old marine worms? Climate change. 100 million years ago, our planet was experiencing an extremely warm climate, with sea surface temperatures as much as 10 degrees warmer than they are today. And it turns out the amount of oxygen available in ocean waters, and thus the amount available to the worms living in the sediments below, is partially controlled by the temperature of the water. The warmer the water, the lower the oxygen content. This will have detrimental effects on marine life as our current oceans continue to warm. So wouldn't it be nice if we could go back and sample these ancient oceans to measure how much oxygen was actually lost, to help us predict what our future oceans might look like? Well, that's what my thesis aims to do. And no, I don't have access to a time machine, but what I do have access to is the burrows constructed during this event. And changes in these burrows reflect changes in the amount of oxygen available to these worms. How so? Well, think of times when humans experience a strain on resources, like in times of famine. We conserve our energy and our populations get smaller. The same thing happens to worms. In times of lowered oxygen availability, worms will decrease their body size to optimize their oxygen requirements, and their population densities decline. This ultimately results in small and sparse burrows being preserved in the ancient sedimentary record. And so by tracking the changes in the size and the amount of these burrows, we can actually track changes in the amount of oxygen from oceans 100 million years ago. So can these ancient worms help us predict our futures? They just might be able to.
Our next presenter, Alexis St. Pierre from the Neuroscience and Mental Health Institute. Alexis's talk is called Different Strokes for Different Folks.
I would love it if everybody could give me a big smile. Now, if everyone could raise their hands above their heads, and if everybody could say hello at the count of 3, 2, 1. Hello. Fantastic. It appears I do not need to call 911, as no one in the room looks like they're having a stroke. The 3 symptoms I watched for today were facial drooping, weakness in the arms, and speech difficulty. These are the main symptoms you should look for if you're unsure whether someone you know may be having a stroke. In case you forget, it goes by the acronym FAST. And you should act fast, because having a stroke is like coming home to your house being on fire. The longer you wait and watch, the worse things will get. Every year, 15 million people worldwide are affected by stroke, and over 50% of these people will suffer from permanent disability such as paralysis, speech impairment, and more. I know it doesn't have to be this way, which is why my research is focused on improving blood flow to the brain after stroke occurs. Let me break it down. Picture the brain as a city, where the blood vessels are the roads, and the blood flowing through is like traffic. In a healthy brain, blood flows rapidly through the larger blood vessels, like cars on a highway, and more slowly through the smaller blood vessels, like cars on narrow side streets. Ischemic stroke occurs when blood supply is cut off to part of the brain, typically by a clot in the large blood vessels. This is like a car crash on the highway, where the clot is the accident holding up traffic. When this happens, cells within the brain can begin to die within minutes, and this leads to major consequences such as permanent brain damage and the disabilities associated with stroke. So, what happens when there's a crash? Well, we call for help, and the body calls for its frontline immune cells, which are the neutrophils. Neutrophils are a type of white blood cell that help heal damaged tissue and resolve infections. Neutrophils are kind of like paramedics, who are often first on the scene to promote healing. For many diseases, this is a good thing, but for stroke, think again. Imagine we all call for help, and every ambulance in the city rushes to the scene of the crash. They take the side streets to get to the highway, but end up clogging these streets, making traffic even worse. This is essentially what happens during stroke. Neutrophils rush through the smaller blood vessels to get to the site of damage. However, since neutrophils contain sticky receptors on their surface, they often end up getting stuck. This creates new blockages and further prevents the brain from receiving oxygenated, rich, nutrient-filled blood. Now, this is where I come in. I'm researching ways to safely prevent neutrophils from creating blockages in the small blood vessels. You can think of me like a traffic director. My research uses human blood samples containing millions of neutrophils within to determine what treatments might decrease the number of sticky receptors on their surfaces. This will allow us to determine how we can improve blood flow post-stroke. So, while I won't be spending my 2 years at the U of A directing real traffic, I hope to implicit real change with my research.
Our next presenter, Sophie Benaroya from the Department of Earth and Atmospheric Sciences. Sophie's talk is called Making a Mars Cake.
How do you unbake a cake? Imagine tasting the most delicious red velvet cake and needing to figure out how to make it yourself. Where do you start? Maybe you look for recipes for other cakes that might be similar, or you go out and you get some of the ingredients, like chocolate or cream cheese. Wherever you start, the only way to know that you got it right is to try making it yourself. That's what I do, but for the planet Mars. You might be wondering what Mars and a red velvet cake have in common, except for maybe the color. Well, my research involves recreating the types of rocks seen on Mars to better understand how magma, or liquid rock, mixes and moves around inside Mars before reaching the surface, like by erupting from a volcano. So, to make my Mars cakes, I first start by getting my ingredients. The ones I use are less appetizing than what you'd find in a real cake. They're things like chromium, titanium, and silica. Once I have everything mixed, I put it in an oven, a special oven, because it has to heat stuff up to around 1200 degrees Celsius, and I let it bake for a couple of days. Once it's ready, I take it out and let it cool before slicing a piece to study. Now, while my baking experiments are helpful in understanding how things can mix together inside of Mars, they're more like crumbs of an entire Mars cake. Maybe you've noticed how when you take the lid off a boiling pot of water, the whole room fills with steam. Rocks are like that too. They can hold gases, so things like water and carbon dioxide, in them when they're hot and under pressure. But when the pressure is released and they cool, they release their gases, sometimes all the way up into the atmosphere. Now, billions of years ago, when Earth was an inhospitable ball of magma, scientists think that Mars was warm and wet. But when we look at Mars now and we study its rocks, they tell us that Mars is really, really, really dry. I mean, the rocks in that Mars cake are inside of what used to be a lake. We're not sure how much water is inside underground on Mars now, or how much there used to be millions of years ago. It's hard to measure something that's now gone. So instead, we have to turn to the rocks themselves and their building blocks, minerals, to see how they might have changed because they mixed with water or they lost it almost completely. So in order to better understand how different areas of Mars might have changed over time, I'll be using what I learned from my experiments to model how rocks and minerals changed over time and try to determine what effect things like water and carbon dioxide might have had on them, which can help us better understand Mars's geologic history. That is the icing on the cake. Thank you.
And our next presenter, Chris Changyan Phillips from the Department of History, Classics, and Religion. Chris's talk is called Millions of Specimens Are Ours for the Taking.
As a member of the Jurassic Park generation, one of the most sacred moments of my life was hiking up to the Walcott Quarry a few years ago, high up in the Rocky Mountains in Yoho National Park. It's part of the Burgess Shale, where fossils tell us what it was like to swim and dig and eat 500 million years ago. Now, paleontologists like Charles Doolittle Walcott are famous for studying the fossils there, but this place means a lot to other groups too, to visitors, to indigenous groups who are excluded from the parks. So in my research project, I tried to find out how scientists got access to these spaces and who else parks excluded. I looked for clues in government records and museum archives, in permit requests, receipts, and old letters. And here's what I found out. Walcott was head of the Smithsonian Institution in Washington, D.C., and the first time that he traveled to Yoho on the train was in 1907. Now, you might think that he needed permission to dig up fossils, but Canada's parks were new, and they actually didn't have the authority to demand that anyone get a permit. And in fact, parks and railways advertised trilobite collecting as a fun thing for tourists to try. One Yoho brochure said, "Millions of specimens are ours for the taking. We gather them as one gathers blueberries in a blueberry swamp." Still, traveling from Washington was expensive, and Walcott often brought his family out to do fieldwork with him on the train. Luckily for them, sometimes the Canadian Pacific Railway gave them free train tickets. Why? Well, he and his wife, Mary Vox, published landscape photos and magazine articles about the places they visited in parks, and they persuaded railway officials. This was great marketing. In a lot of ways, Walcott reinforced the image of parks as playgrounds for white, wealthy visitors, maybe most of all through how he named the fossils. He named them after lakes and mountains and railway stops on the new colonial maps of the Rockies. And in exchange, the Park Service did favors for him, like looking the other way when a member of his team illegally shot a sheep. Meanwhile, First Nations who lived in the area, Stoney and Secwepemc and Ktunaxa people, were banned from living and hunting there, and sometimes testified about being put in jail for owning meat hunted off reserve. Research like Walcott's helped the Burgess Shale earn a spot on the World Heritage List in 1980. And so many visitors came out and wanted to take a piece home that park staff worried there wouldn't be a Burgess Shale left. So they shut down public access to the beds. And now if you want to get in, you have to pay for a spot on a guided hike. And you definitely can't take anything home unless you want to pay a couple $1,000s in fines. Canada has some very ambitious goals to protect new lands and waters by 2030, many of them in parks. And I hope my thesis encourages parks managers and paleontologists to consider the way that scientists' interaction with park spaces can make it difficult for other groups to get close to them. Thank you.
And the next presenter, the final presenter of the evening, Arushi Tandon from the Department of Biomedical Engineering. Arushi's talk is called Seamless Transitions from Disability to Dignity.
If you know someone who uses a wheelchair or needs help with mobility, please raise your hands. Now take a look around this room. 1 in 10 Canadians suffer from mobility issues, and 1% of the world's population, which is 75 million people, require a wheelchair on a daily basis. One of these 75 million people was my grandmother. The biggest problem she faced, and every wheelchair user faces, is using the restroom. For this simple task, we had to lift her from the bed to the wheelchair, then from the wheelchair to the toilet, and then back again. If she had to use the restroom 10 times, we would have to lift her 40 times. Not only is this risky for both her and the caretaker involved, it also created a sense of shame and dependency in her. It almost pushed her into depression. I looked at alternative devices on the market, like medical cranes. They are expensive and don't actually solve the problem at hand. Why do we need to lift a patient at all? So I decided to build my own device, a bed wheelchair. Here's how it works. The wheelchair is a part of the bed. So the patient lying on the bed is seated and the wheelchair slides out like a drawer in a cabinet. It can be controlled using the joystick. The armrest and backrest can be pulled up and this becomes any normal wheelchair the patient can use. To use the restroom, there's a hole in the seat which can be removed, and the wheelchair, being hollow, slides over the toilet. After use, the removable part is reinserted, the armrest and backrest are pushed down, the wheelchair once again slides in to become a part of the bed. You may notice that in this entire procedure, the patient is not lifted even once. You may realize that they can navigate this entire process by themselves without the help of a caretaker. This design was in fact so successful, I patented it and then shared it with the many, many patients who requested that I build it for them. It has successfully served my grandmother well for the last 7 years, until now. Last month, she was hospitalized, and these same problems repeated themselves. She was not able to use the restroom and lost her freedom one more time. And this is where the biggest need for this wheelchair is, in hospitals and old age homes. So this is what I am going to do next. I'm going to integrate this wheelchair with a hospital bed so that nurses and clinicians can perform all the complex functions required of the bed, such as lifting the patient upright, hanging an IV line, and so on. While at the same time, a patient can maneuver themselves to use the restroom independently of a nurse's schedule. This wheelchair has already saved one life, my grandmother's, and I'll make sure that it helps millions more. Thank you.
Wow. I'm in awe of the storytelling ability, the communications, the passion, and all of the incredible research that you all just talked about and everything that I learned. Let's thank all of the presenters one more time. It was just incredible. Thank you so much. Now the judges' hard work begins. Well, we get to enjoy the afterglow of the great presentations we've just heard. So while Renee ushers the judges into their deliberation room, we'd like to invite you all, our in-person guests, to step outside, stretch your legs, and enjoy some appetizers and refreshments while the judges do their work. We'd also ask that you take this opportunity to vote for our People's Choice recipient. You can do so whether you're joining us in person or online. Just consult your phone or your tablet and go to uab.ca/3MT. Again, one more time, that's uab.ca/3MT. Don't wander too far. We expect to reconvene in 20 or 25 minutes at around 6:10. Are we on time? We are on time. And that could come quickly. So be listening for our announcements. So please go enjoy some refreshments while the judges deliberate. Thanks, everybody. right. Okay, welcome back, everyone. Woo. This really is like, this is like our Oscars. Right? I feel like, totally. So the judges have reached their decisions. They are back, and in just a moment, they'll announce them. But while they prepare, I want to say again, bravo to all 15 of our superb finalists. If it was up to me, I would send you all to the Western Finals at UBCO in a few weeks. You're all winners, and I want to stress what an important accomplishment this is and how much we appreciate the work and the time that you've put into this project. It's really spectacular. We trust that every minute you devoted to your 3MT will pay off for you. I had the opportunity to talk to a few of you at the break, and I know that this experience is going to come in handy explaining your research to your families, actually doing legit elevator pitches, so hopefully it pays off in all kinds of ways for each of you. And now I'm going to call each finalist to the front and give everybody a certificate acknowledging this accomplishment. So Jessica Van Oss. You got to stay up here. We're getting a group picture. Okay, Ashira Manzur. I said it wrong. Ashra. There, I corrected myself. I got it. Ron Miguel Burtonshaw. Alexandra Gagnon. Haley Woljan. Brandon Tyre. Amy Callahan. Megan LaRock. Rafeh Asmani. Janani Radhakrishnan. Sarah Biddle. Alexis St. Pierre. Sophie Benroya. Chris Chang-Yen Phillips. And Arushi Tandon. Yeah, you're the professional.
We'll do another group shot at the end. Later, after.
This is really just building suspense. Yeah. Congratulations, everybody. Stay. We're not letting them go yet. Now I'd like to call all the judges forward and thank them as they're walking up here for the hard work that they did. Are there any comments you want to share before we deliver the big news? Yeah, please. Go ahead.
Well, first of all, congratulations to all of the participants. It was really a remarkable experience to see this. You know, as a publisher and as an owner of a marketing firm, and really my whole life, I've used a remark from James Humes, who was a presidential speechwriter for Eisenhower through Reagan. And he said the art of communication is the language of leadership. The art of communication. So you can have the best idea in the world, but if you can't communicate it, it's going to go nowhere. So thank you that all 15 of you did a really, really excellent job of communicating what you are going to do to change the future. So I really appreciate that. Thank you so much.
That's fine. No, that's fine, that's fine. I just want to say that was a very difficult decision for all of us. Everyone did an excellent job, and I just want to congratulate everyone on your hard work. And we're looking forward to announcing the winners as well. But I think we have a room full of winners here, if I had to say.
So you guys have really, in some ways, made my job easier, because part of my job is to make sure that the great research that we have here at the university moves out of the university into the community. And I think every one of you talked about the impact your research has in terms of how it can be applied. And that really makes me feel good. So keep doing that. It is really, really exciting to see the breadth of research that we're doing here at the university and the impact that we are having here. So congratulations. This was a really tough decision, but really great work.
Okay, thank you again so much to our judges. Okay, so now the moment we've been waiting for. I'm going to invite Sapreet again to the microphone to announce the runner-up of the 2023 University of Alberta 3-Minute Thesis competition. When you hear your name, this person, we'd ask that you come forward to receive your certificate. So Sapreet, I'm going to turn it over to you.
Thank you. So I am very excited to announce that the runner-up is Ron Miguel Burdenshaw.
Congratulations, Ron. Yeah, oh, you're good, you're good. And now, Trudy, over to you to announce the winner.
Okay, well, thank you. The winner of the 2024 U of A 3-Minute Thesis is Alexandra Gagnon.
Don't go anywhere yet.
Yeah. Congratulations again.
Congratulations. And we're not finished yet. One of our favorite parts of the day is honoring the person whom the audience has voted their favorite. So it's the People's Choice Award. And Darren, we're going to get you to do the honors here.
Okay, I do a drum roll, but I really suck at that sort of stuff. So, and the winner of the People's Choice Award is Alexandra Gagnon. Congratulations.
Congratulations, Alexandra. You've got too many awards to even hold. It's amazing. So before we close the proceedings, we'd like to give Alexandra the chance to say a few words if she'd like.
First, I have a few thank yous I'd like to make. I mentioned it in my talk, but I'm part of a team that's working on this project together. And I'm so, so fortunate that I have my team members here with me today. If you guys want to give a wave, I'd like to ask if we could give them a round of applause too, because this research isn't possible without them. Second, I'd like to give a thank you to my supervisor, Dr. Sandra Bucerius, and to Dr. Kevin Hagerty for all of their help that they've given to me throughout this degree. As well, I'd like to give a big thank you to all the work that you've done. It's been awesome. This experience has been so awesome, and it's been so cool hearing everyone's research and getting to hear about stuff outside my faculty. And also a big thank you to all of you guys for everything. This has been a really, really great experience, and for all the help and all the feedback you guys have given. And lastly, my mom's in the audience, so I want to say thank you to my mom. Thank you for supporting me. And if you're interested in learning more about the research that we're doing at the Center for Criminological Research, you can find us, you can Google us, we're at the University of Alberta. There's so much meaningful work and different projects that are being done, so if you have any questions or are interested, please don't hesitate to look us up or to ask us any questions. Thank you.
Wow, it was just so amazing. Before we close out our ceremonies, I want to continue on with something that Alexandra mentioned, which was that This event today, I think, has been really amazing, and I know we've all really enjoyed our time here. But the preparations and the work that go into the 3MT start a long time ahead of this evening. And in fact, they started last year before the holidays in December. So I really want to give a shout out to especially the professional development team at GPS, Renee Polzine, Rob Desjardins, Aaron, who's sitting over here, and Jay is somewhere at the back. They've been working on this for months, including spending a lot of time with all of the students that decided that they wanted to participate in the 3MT and see what that was all about. So everything that you saw here tonight started a long time ago. There's been a lot of professional development and work on communications that's gone into this, a lot of peer support that I've heard about from this fantastic group who's actually really given each other advice and guidance around their presentations that you heard tonight, and it's just been an amazing community of practice. So I want to give a round of applause to the group and the students that have been working on this for a long time. Okay, that brings us to the end of the formal program for today, but not the end of the 3MT for 2024. So if Alexandra is able, and I hope she will be able to, she'll be moving on to compete in the Western Regional Competition in Kelowna. Woo-hoo! So let's all cheer for Alexandra in Kelowna. Hopefully she's able to go. And I'll just finish off by thanking all of you for coming, thanking all our presenters, thanking everybody at GPS behind the scenes that put together the incredible spread out there and all of the events this evening. So thank you for coming and have a good evening.